This is lesson 2.4, multiples, factors, and prime factorization. In this lesson, we are going to be talking about multiples of a number, what it means to have a multiple of a number. We're going to review divisibility rules. So when you're looking at a number, you can tell if it's divisible by 2, 3, or 5. We're going to talk about the factors, which will pretty much get us ready to do fractions in chapter 4, in unit 4. We'll talk about prime and composite numbers, and we will do some prime factorization. I am going to use the ladder method here in this unit in my lecture, and in the homework you have a video on the tree method to do the prime factorization. So one of the other methods that will be more acceptable to use or more comfortable, convenient to use, it's going to be your personal preference. All right, so let's go ahead and start with the definition of a multiple of a number. And you see those multiples when you look at a multiplication table, for example. A number is a multiple of number n if it is a product of a counting number and an n. So that's a mouthful. So a counting number would be 1, 2, 3, 4, 5, and 6. Okay. So when you look at your multiplication table, let's go ahead and see if I can grab my multiplication table at the beginning of our, all right. So pretty much the multiplication table has all the multiples of a number. All right, so here, numbers are going to be on the left. So these are our numbers. And this would be counting numbers. All right. So let's say a 2. 4 is a multiple of a 2 because it's a product. So 4 is a multiple of a 2 because it is a product of a 2, which is a number, and a counting number, another 2. 2 times 2. Let's go look at the 12. 12 is a multiple of a 2 because it's a product of a 2 and a counting number, which is a 6. So 2 times 6 would be 12. All right, so that's how we go with multiples. Okay. So let me go ahead and fix that because I don't need this anymore. All right, and let's go back to our section. Whole numbers. Here we are. Here we go. All right, so multiple of a number. All right, so we can, we're ready to write our little example here. So for example, 2 times 6 equals 12. So this is going to be your number. This is going to be counting number. And the 12 is going to be a multiple of 2. All right, so that's how you get all the definitions in there. Okay, so again, if you need to know if the multiple, if a particular number is a multiple of another number, just double check your multiplication table or remember your multiplication facts. Okay, divisibility tests. Okay, sometimes when we, and especially when we start looking for a common denominator, we're going to need to check the number for a divisibility rule. So the divisibility test, we only have a few of them that we're going to review. So a number is divisible by 2 if it's an even number. The last digit is 0, 2, 4, 6, 8. So all even numbers, pretty much all even numbers are divisible by 2. The number is divisible by 3. Okay, so the next line, the number is divisible by 3 if the sum of digit is divisible by 3. So let's say I have a number 711. Okay. So let's say you have 711. Okay. So it is divisible by 3 because 7 plus 1 and plus 1 equals 9, and 9 is divisible by 3. So that's how you check for divisibility by 3. Not a very common skill to have, but if you kind of wanted to learn that, this would be a skill. 5 is easy. Divisibility by 5 is easy. If you look at your multiplication table, the last digits of all those multiples are either 5 or 0. So if a number ends in 5 or 0, it is divisible by 5. 6, we're going to skip the 6. It's not very useful because we can always do the 2 and then 2, 3, or 5. That will get us through all the divisibility rules. And the last one is if the number is the last digit is a 0, the number is going to be divisible by 10. We'll use that divisibility rule quite often in this course. Okay. So now that we have these rules, you know those basic rules of the divisibility, let's go ahead and in our example 1, determine if the number is divisible by 2, 3, 5, and 10. Remember, we're not using 6. 6 is kind of nice to know, but it's a little bit more involved because the number has to be divisible by 2 and 3. Okay, so 1290. All right. This number is even number, so it's going to be divisible by 2. All right, so divisible by 2. It also ends with a 0, so it's going to be divisible by 5, divisible by 10, so I can tell that right away. But in order for me to figure out divisibility by 3, let's go ahead and double check that. 1 plus 2 plus 9. So that would be 12. And it is divisible by 3 because 12 is divisible by 3. So 1,290 is divisible by 2, 3, 5, and 10 by all 4. All right, so we're going to go look at the next one, 7,248. All right, so we know it's going to be divisible by 2 because it's an even number. So it is divisible by 2. So let's go ahead and add the digits. 7 plus 2 plus 4 plus 8 to check for divisibility by 3. So we're going to have 10 and 7 plus 4 is, so we have 21. So it is divisible by 3 because 21 is divisible by 3. So it's a yes. Okay. Let's see. And in order for us to be divisible by 5 and 10, it needs to end either 5 or 10, and it's not. It's 5 or 0, and it's not ended in 5. It's not, the last digit is not 5 or 0. So this number is only divisible by 2 and 3. Okay. So, and then part C, go through the same process. Now the last digit is 2. It's an even number, so it's divisible by 2. So in order for me to check divisibility by 3, I have to add the digits. 4 plus 9 plus 6 plus 2. All right, so I have 10 and I have 11, so it's 21. So it's divisible by 3. And then again, I can't do 5 or 10 because it is not, it's in, the last digit is 2 and it's not 0 or 5. Those are my benchmarks for 5 and 10. So just 2 and 3. Okay. All right. So that's the divisibility rules. Nice skill to have. If you don't have it, you don't have it. Just remember, if you're going to remember anything for divisibility rules, remember that the even numbers are divisible by 2, and those who end at 5 or 0 divisible by 5. Those that end at 0 divisible by 10. Those are the easiest rules to remember. 3, again, it's a nice skill to have, but it's not required. All right. So Why do we need this divisibility is because we're going to be breaking the big numbers into small numbers into factors. All right. So when you multiply the two numbers together and you get the sum, the numbers being multiplied are called factors. So if a times b equals m, some number m, then a and b are factors of m. So let me give you an example. So if 6 times 7, 6 times 7, let's just try to remember, equals 42, then 6 and 7 are factors of 42. All right. And some of you may remember back in school, there's more than one way to write the factors, and it doesn't have to be just two numbers. There could be multiple factors of the same number because I can break 6 a little bit further down. The factors of 6 are 2 and 3 because 2 times 3 is a 6. All right. So to find the factors of the following numbers, think of all the ways that you can use multiplication of two numbers to get to the number that you're given. All right. So what factors the following numbers would present? 24. 24 could be given as 2 times 12. I can do 3 times 8. I can do 4 times 6. All right, so 3 ways of getting 24. So 2 times 12, 3 times 8, 4 times 6, all of these are factors of 24 because multiplying those numbers, you get 24. 42. How do you get 42? You can do 21 times 2. You can do 6 times 7. And that's pretty much it if we're just looking for two numbers. So let's just stick with two numbers. We're gonna break them into smaller pieces a little bit later. Okay. So the next one's 60. 60 could be 6 times 10, 30 times 2, 15 times 4, 20 times 3, and so forth. You get the idea. All right. So those are the factors of 60. And then we have 2. The only way to get 2 by multiplication is to multiply 2 times 1. We haven't used multiplication by 1 because it works for every single number. We can add that to the other multiplications. So I can do 24 times 1. I can do 42 times 1. And I can do 60 times 1. That's a given. But with 2, it's only 2 times 1. There's no other way to get the 2 using multiplication. So is the 7. There's no other numbers that go into 7 but 7 times 1. If I were to rewrite 7 as a multiplication problem. So that brings us to an interesting observation. As you have seen from these 4 examples, some numbers have more factors than the others, and some numbers can only be written one way. All right. So the part D and part E, okay, those are the ones that are the special cases. So now we're ready to talk about the prime and composite numbers. In part D and E, because there was only one way of writing the factors of these numbers or writing those numbers as a multiplication problem, we call them the prime numbers. Prime numbers divisible by 1 and itself. Composite numbers divisible by other prime numbers. So if you can think of more than one way of representing the number through multiplication, that would be a composite number. So that would be our part A, B, examples A, B, and C. But if there is if you cannot think of any way except for multiplying that number by 1, that means it's a prime number. Okay? So prime divisible by 1 in itself. The smallest prime number is a 2 because 1 cannot be represented because 1 is already itself, so we cannot use it multiplied by 1. All right, so here's our reference table for prime and composite numbers. So again, the smallest prime number is number 2 because it has factors 1 and the number itself. Okay, we cannot use 1 as the smallest prime number because it cannot duplicate 1 times 1. Just cannot do that. All right, so 3 is a prime number as well because the only way you can represent 3 is through multiplication is 1 times 3. But 4 is a composite number because you can do 1 times 4 or 2 times 4. No, 1 times 4 or 2 times 2. So there's 2 ways of representing 4. 4 can be either 1 times 4 or 2 times 2. 5 is a prime. 6 is a composite because there's more than one way of representing 6. You can do 1 times 6 or 2 times 3. Okay, so that's why 6 is composite. So this is a nice little reference sheet to study. Make sure that you understand this and notice that the prime numbers are all highlighted in the dark, in a darker color. So we have 2, 3, 5, 7. Then the next prime number is 11. Then we have 13, 17, 19. So we'll stop at 20 because that should be enough for the purposes of this course. Okay. So prime factorization is the process of breaking your numbers into their factors. Okay. So the prime factorization of a number is the product of prime numbers that equals the number. Okay. So again, we're going to be breaking the numbers down using multiplication to the smallest pieces. And we're going to stop when we only have the prime numbers being used in that multiplication. So for prime factorization, here in this lesson, I am going to use the ladder method. So the ladder method for prime factorization has 5 steps. So the step 1, divide the number by the smallest prime. So you're always going to try to check for 2. Okay, 2 or 3. Those are the smallest primes. Okay, 2 or 3, or maybe even 5. All right. Continue dividing until no longer divides evenly. Divide the next prime until no longer divides evenly. Continue until the quotient is a prime. Write the composite number as a product of all primes. All right, so let's go ahead and start with that. So we have 126. All right, if I divide 126 by 2, it is divisible by 2, it's an even number. So I have 126 divided by 2, I am going to have 63. All right, so I have 2 times. All right, so that's my first 2. All right, so then now that I have 63, 63 is not divisible by 2, but it is divisible by 3 because 6 plus 3 is 9. So I can do 63 divided by 3, that's my next prime, equals, that would be 21. 21. So the next factor was 3. Okay. So, and now I'm going to work on 21. 21 is divisible by 3 and 7. So divide by 3 again, equals 7 times 3. And 7 is prime. So I don't need to do any more divisions. So this is the prime factorization for 126 is 2 times 3 times 3 times 7. All right, and now that we know how the ladder method works, let's go ahead and actually do the actual ladder. All right, so I'm going to rework this problem using the ladder. Okay, so we're going to start with 126. All right, so 126, all right, is divisible by 2. All right, so when I divide 126 divisible by 2, so I am going to get 63. Okay, so 63 becomes my next step in the ladder. 63 is divisible by 3, right? So that is going to give me 21. That becomes my next step in the ladder. 21 is divisible again by 3 and gives me the 7, and the 7 is the prime number. All right, so those are my factors, 2, 3, 3, 7, and I just need to rewrite that factorization, the answer as the product of all the factors. So the prime factorization of 126 is 2 times 3 times 3 times 7. Okay. So let's go ahead and do the 294. Okay, so we're going to start with the 294. Now it ends in a 4, it's an even number, so I'm going to go ahead and try the 2. Okay, so 294 divided by 2 is going to give me 147. That's an interesting number. 147 is not divisible by 2, but it is divisible by 3. Right. So my next step of the ladder is the 3. So 147 divided by 3 is going to give me the 49. Okay, so 49. 49 is 7 times 7, so it is divisible by 7, and we have the answer is 7. So now that I arrived to the prime number in my answer, those are my factors, 2, 3, 7, 7. So I'm going to write the answer as 2 times 3 times 7 times 7. Okay. So 455. Let's start on the bottom of my ladder. 455. All right, ends at 5, so I know it's going to be divisible by 5. So I'm going to have 91. Okay. So 91 is an interesting one. It is not divisible by 2. It is not divisible by 3. I know it's not a 6. It could be divisible by 7. It sure is. It is divisible by 7. So there is no rule for divisibility by 7. You just have to try it. So in the 91 divided by 7 is going to give you 13. And 13 is a prime number. So you have 5, 7, and 13 as your answer. Five times 7 times 13. All right. We have lost one, 693. Okay. So I know it's not going to be divisible by 2 because it's not an even number. 693. All right. So let's see. 6 plus 9 is 15 plus 3 is 18. So it is divisible by 3. So I can divide it by 3. 231 is the answer. So let's double check 231. Again, it is not an even number. So I know it's not divisible by 2, but 2 plus 3 plus 1 is a 6. So it's further divisible by 3. So I can divide that by 3 to get 77. All right. 77 is divisible by 7. Okay. So remember, it's the smallest prime number. It is divisible by 11, but we're going to go for 7. So divisible by 7, and that would be 11. And 11 is a prime number. So I got all my prime numbers here. I've used them for my division. So I got 3, 3, 7, 11. So those are the ones that I need to list as my factors. So 3 times 3 times 7 times 11. So this is how the ladder method works. The tree method is, you have a video of it in the homework, so watch the tree method, and then use whichever method you are most comfortable with.